Hello, today I have lesson 2.1 integer exponents, and I have a little puzzle up here on the board for you. If you're interested in solving it, you don't have a partner, this is what we did last year, come up with a solution. I'll give you a couple of minutes. Okay, today we are going to work on the exploring properties of integer exponents. Complete the following equations. So I have 3 times 3 times 3 times 3 times 3. I have 1, 2, 3, 4, 5 threes. In my parentheses, I have 1, 2, 3, 4 parentheses, and then 1 outside. So all together, I have 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 1, 2, 3, 4, 5. What pattern do you see? When I had no grouping symbols, I had 5. When I had grouping symbols, I had the 4 and I had the 5. So it's like saying plus here. 4 plus 1 is 5. Then I had 3 grouped together and 2 grouped together. Well, 3 plus 2 is 5, and I have 5 threes. Use your pattern to complete this equation. 5 to the second power times 5 to the fifth power. How many 5s do we have altogether? Well, we have 2 plus 5, and that is 7, so I have 5 to the seventh power. Here's one for division. I have 4 to the fifth power and divided by 4 to the third power. When you are dividing, it helps if you spread them all out to take a look at them. And then we can cancel out our 1 pairs. So there's a pair, and there's a pair. And how much am I left with? I'm left with 4 times 4, so that's 4 to the second power because there's 2 4s. Another way I could have done that is I could have taken 5 minus 3 gives me 2. Those are my exponents. Sorry about that. So these are my exponents. 5 minus 3 is 2. So this gives me 4 to the second power. When we use the pattern to complete this one, we have 6 to the 8th power over 6 to the third power. So if I do that, then I have 8 minus 3. 8 minus 3 is 5. So I have 6 to the fifth power. When I see something like this, this is telling me that I have 5 to the third power times 5 to the third power. And so 3 plus 3 is 6. Oh wait, not there. To the sixth power. So I have 5 to the third power twice. I'll get this right yet. So I have 2 sets, and altogether I have 6. What pattern do we see? When you have 5 to the third power inside a square, you're going to multiply. 2 times 3 is 6. 5 to the sixth power. I have this equation, 7 to the second power inside parentheses to the fourth power. So knowing this, 7 to the second power times the fourth power, I get the 2 times 4, which is 8. Okay, let general rule for the value of a to the m power times a to the n power. The bases are the same, so we're just going to add those two. So we have a m plus n. This is division. Remember, we're subtracting our exponents if they have the same base. A to the m minus n. I'm actually going to put these in parentheses. this one, I have a to the m to the nth power. So then this one's going to be a to the mn, because that's multiplication. Applying properties of integer exponents. Knowing what we know, we can take some of this and work it through using order of operations to help us. So the first thing we're doing is we're looking at this problem. Inside parentheses, 5 minus 2 to the 5th power times 3 to the negative 8th power plus 5 plus 2 to the 0 power. Well, first of all, we know that 5 minus 2 is 3. This one we didn't change. And 5 plus 2 is 7. So then we get 3 to the 5th power times 3 to the negative 8th power plus 7 to the 0 power. And remember, anything with a 0 power is equal to 1. So we're going to bring this 1 down. Then I have two bases that are the same, 3. And remember, when they're the same and they're being multiplied, we just add them. So we're going to take 5 plus negative 8. 5 plus negative 8 is negative 3. So we have 1 and 1 over 27 plus 1. And you add those two together, you get 1 and 27. This, remember, is the same as 1 over 3 to the 3rd power. 3 times 3 is 9, times 3 again is 27, and that's where they get this 1 over 27. This one here is division. Again, we're going to work what's inside the parentheses first because that is our order of operations. 3 plus 1 is 4. So we have 4 to the 2nd power to the 3rd power over 4 to the 2nd power. I can get rid of this here by doing what we know with multiplying our exponents. We can take 2 times 3. That gives me my 6. And I still have the 4 to the 2nd power, but we remember when they're division, we're going to take our 6 minus 2, our exponents, and that gives us 4. So we have 4 to the 4th power. And when they ask you to simplify it, go ahead and find the final total. Okay? We're going to work on these here in just a moment. So I would like for you to go ahead and work them on your own. And then when we come back, we'll go over them together as a class.